Wow, hello, thank you very much for coming, and welcome to Crash Burn Report, which is my talk title and hopefully not what I'm going to do. So I'm here today to talk about a couple of new features that are being introduced into the browsers, and we already have support, as was just mentioned there in Chrome, but we're hoping to see more widespread support very soon. Now, we do have to have the support discussion. Every time I talk about a new browser feature, most people think, great, like, are we going to have to polyfill this? Is the support going to be good, bad? And it actually doesn't really matter so much, because the features that I'm going to talk about are there to help you as an application owner, as a site developer. And whether or not the browser supports them doesn't matter so much, because if the browser supports them, the browser will help you. If the browser doesn't support it, it will simply do what it did before and not help you. So I'm sure many people here, like me, have a website. I have my own blog. You could have a company site. You could have an application, e-commerce. It could be anything. We all have a presence online like this somewhere, and we want to make sure these things work. I have my blog. I write blog posts. I want people to come to my website and to be able to read them. But things don't always work. Things can go wrong. And in a typical browsing scenario, we have the browser. It comes along to, let's say, my website, and it will make a request. The request lands on my server. Now, things can already start going wrong here, and we have lots of different tools to help us track when things go wrong. I'm sure many people here recognize some of these. I've used New Relic in the past myself. I currently use Papertrail. If my application server isn't behaving properly, if there's some kind of problem, maybe it's low on resources, there is something wrong, I have the tools at my disposal to know that there is a problem, and for me to then be able to diagnose and fix that problem. And likewise on the client side as well. I'm sure with the response, many people here send frameworks and tools over to the client to track client-side issues. Again, if the client has come to your website and something has gone wrong, you want to know about it. These tools are here to monitor and track errors and send them to you. So this is really good. And this demonstrates that we do want to know when things go wrong. We want to be able to be aware of them and to fix them. However, these tools can't always help us, because there are some scenarios in which none of them will work. Perhaps this happens. Now, this particular error here in Chrome, I've done a lookup for a subdomain on my site that doesn't exist intentionally, and the browser throws an error and says, I could not resolve the domain. Of course it couldn't resolve it, because it doesn't exist. But the point is, a user, for some reason, has tried to come to this part of my website, and something has gone wrong. They're now seeing an error message. How do I know about this? How do I know that this has happened? And there's countless other scenarios like this where the user can see an error message when trying to access some part of your application, and there's no way for you to currently know about that, because here the DNS did not resolve. Now, if the DNS didn't resolve, then what that means is no request was sent. Because if we couldn't resolve the domain, the browser can't send a request. If there's no request, then none of these server-side monitoring solutions are going to help us. Likewise, if there is no request, there's also no response. So there's nothing on the client side either. The user is simply sat at a full-screen error message on your site. And this is one of the things that we're going to try and resolve. When we have these errors, we can now use something called the Reporting API, which is built into the browser to learn about all of these error cases and these scenarios. We're going to talk through a few more examples of right now when we can't know about that. Because what the Reporting API does is, in this scenario where for some reason the communication between the browser and your application breaks down, we're introducing an out-of-band reporting mechanism for the browser to send those reports somewhere else. Now, in the interest of full transparency, I do run a service, which is our logo up there, that accepts these reports. But as you'll see very soon, they're simple JSON payloads sent out of band by the browser, and you can send them anywhere you wish. Now, in order to do this, you have to ask the browser to do this. The browser needs to know that in these error cases, you want it to send those reports. And it's super easy to turn on, because number one, this is native functionality in the browser. You don't have to deploy any code or an agent or anything else. This is native built-in functionality in the browser itself. All you have to do is turn it on. And to turn it on is super simple. You issue a HTTP response header called the report to header, which you can see on the third line just here. Now, inside the header, as you can see, we're going to deliver some JSON. And the JSON is the actual configuration. So I'm just going to expand that out so we can see it. This is the content of the report to header that you send to the browser. And what we're telling it here is that, first of all, I would like to create a group of reporting endpoints. So these are the locations where the browser is permitted to send reports. I'm just going to call it default for this example. The browser will cache this configuration for a period of time, defined here in seconds. This is approximately 1 year. So I would like the browser to remember this configuration for a year. The endpoints are then the locations where the browser should send those reports. Now, in here, you can place anything that you want. I've specified a demo account on our application to say, please send the reports, should an error happen, to this location. You can specify multiple endpoints, and the browser will automatically do fallback, should one of these be offline as well. And of course, then includes subdomains. This does as you might imagine. Do you want this to apply to the current domain and all subdomains on your site? Yes, I do. I want full coverage on my application. Now, this configures the browser to send these reports. The browser now knows where to send them. If something goes wrong, this is where we're going to send it. Now you can tell the browser what things you want to know about, what particular types of errors. So we're going to look at something called network error logging. Now, network error logging is probably one of my most favorite features coming out because it covers a whole bunch of things that can go wrong that are really hard, if not close to impossible, for us to know about any other way. Because first of all, it covers DNS. The example that I showed you earlier, when my subdomain did not resolve, you can say to the browser, hey, look, like if my DNS name does not resolve, second line, DNS name not resolved, send me an error report and tell me. Maybe you get a flood of reports coming in from users in France. Something's wrong with your DNS in France. It's not resolving properly. Something is broken, misconfigured. So all of these DNS errors can be caught, and then the browser will send a report to the endpoint that we've just specified. But it's not just DNS. Maybe DNS succeeds. If DNS succeeds, we go to the next stage, which is TCP. We've now done the lookup. We've got to make the TCP connection. Plenty of things can go wrong at TCP as well. All of the different errors are covered here on the screen. For whatever reason, the browser could not make a connection. The connection was closed. It was reset. It was refused. Maybe your application server is having a really bad day. Any one of these errors happens, you will get the report. Even if TCP works, the next step for most applications nowadays is TLS. Most of us have HTTPS on our websites. And a lot of people are doing this recently, actually. There's been a huge push. And when some people start doing things that are new, we kind of make a few mistakes at the beginning. So these are some of my favorite errors, because these are the things we really want to know about. Have you deployed HTTPS onto your website and something is broken? Incorrect protocol versions, cipher suites. Maybe you're using an expired certificate. Maybe you're serving the wrong certificate. But again, who's been to a website and had the big error message with the red warning triangle that says something is wrong with the secure connection? In those normal scenarios, the host wouldn't know about that. But with network error logging, you can have the browser dispatch the report to you and say, hey, do you know your certificate's expired on your website? That's going to be really handy. And then, of course, if we make it through TLS, we can get up to HTTP. We can get up to the application layer. And there are still plenty of things that can go wrong at HTTP as well. Protocol errors, invalid responses, redirect loop. Who's been to a website, usually during an auth flow, and got stuck in a redirect loop, and then the browser just gives up after a few seconds? Again, normally the application owner wouldn't know about that. They wouldn't find out about that. Network error logging, you can get a report sent to you. So to pick up on my favorite one here, is probably the TLS-focused ones, the HTTPS-focused ones, because I do see a lot of these when I'm browsing around the internet. Try to go to a website, you get the big not secure at the top and a big red warning triangle. Something on the website is misconfigured or broken, or something is wrong. Now again, no connection was established here. So none of our standard reporting tools, our standard diagnostic tools, will help us in this situation. But this browser knows that there is a problem. Now, if you want to get all of these types of reports, you need to enable network error logging, as I said. And this is how you do it. This is the whole configuration for enabling all of the reports that I just talked about. You simply issue the NEL header, the network error logging header. Report to default. This is the group that we configured earlier. So you're saying, yes, I would like these reports. Please send them to the group called default. And again, the browser will remember this policy and apply it. Because remember, if the browser comes to your application now, everything will work, everything is fine. But if the browser comes back to your application tomorrow and it's broken, the browser needs to remember, what do I do when things break? This is why we have the max ages, and this is why the browser caches the policy. Because the next time they visit your application, we need it to know what to do. So NEL reporting is fantastic. The browser, when it sends these error reports, it just sends a nice JSON payload. So if you would like to subscribe to a service that does this, ingest them yourself, it's JSON sent as a HTTP post request. Fairly simple and fairly easy to work with. They all conform to the spec, so you can go read the NEL spec and look at the format of the JSON. Age, this value here is 0 because the report was sent immediately. Sometimes, for whatever reason, the browser can't send it right away. The browser may cache the report and send it a little later. The age will tell you how long, in seconds, the browser has held onto this report. Type, network error. What page was the user trying to get to? Sampling fraction. Maybe you don't want 100% of your users to send reports. Maybe you say, you know what, give me 0.1 and we'll take 10%. So you can downsample the errors if you're getting too much JSON. Refer a server IP protocol here. They're empty, but these fields could be populated. The browser tried to make a GET request. There's no status code because an error happened. No connection, no request, therefore no status code. And the last couple of fields, elapsed time. The browser spent 92 milliseconds arriving at this error. And the type of the error, probably the most important one, TLS certificate date invalid. You're serving an expired certificate on your website, therefore the browser cannot connect. And as I mentioned earlier, this is a really common thing. We see this happening a lot. And it doesn't just happen to small organizations and small companies. It happens to really big companies as well. It's not just Microsoft. Loads of large organizations have had these failings where you have a certificate, it's generally valid for a year, and every year you have to renew it. Oops, someone forgot, it expires, your website stops working. So it would be nice to find out about this without having to rely on probably the most reliable, currently the most reliable reporting mechanism. If something's wrong with your website, where are you most likely to find out about it right now? Twitter. Whoever said it, you're correct. This is where we usually find out that a pretty big website is broken, because as soon as a big website has an issue, people hit Twitter and say, hey, Azure, LinkedIn, some bank, whichever organization, you have a certificate that is invalid. This here is the UK website for LinkedIn. And it wasn't just their UK version. They had several different geographic versions around the world, all stopped working because their certificate expired. Now, maybe LinkedIn is large enough to have some other alerting mechanism, some kind of external monitoring. Maybe they're not. Maybe these error reports on Twitter are the first that they heard of this. But we see it with banks as well. I particularly like this one. Somebody here was trying to go to a big bank in the UK called Barclays, buy some home insurance. Hey, got a big error message on your website. Says your site's not secure. I love the response. We see things like this all the time. Could you please try using a different browser? It's like, Firefox says it's not secure. Safari says it's not secure. Try Chrome instead. Maybe that'll be OK. This happens a lot. And with network error logging, you can find out about it the second it happens. Now, to try and put some context onto this, I also run a separate project online. Crawler.ninja is the website. I crawl the top 1 million websites in the world every day and look at countless different aspects of their security. One of them is, how long do they have until their certificate expires? And as you can see here, I produce some raw data files, 7 days, 3 days, 1 day, and sites that are currently online using an expired certificate. There's a surprisingly large number of websites in that list. So these are websites that are online right now and are not accessible in the browser because their certificate has expired. So this is a big problem, and this is just one fraction of what network error logging can help with. But network error logging is not the only feature available to us. All of those things that I've just talked about, they're all there, plus everything that we're about to look at now. So we've covered NEL. We've covered network error logging. What else does the browser know about that it might be able to help us with? So we have something called deprecation reports. And I'm going to use an example here. I've changed the name of the company to protect the innocent. But a recent change was made in the browsers, and it affected a lot of e-commerce websites in the UK. Now, Sainsbury's is a grocery store, a supermarket in the UK. They're a fairly big one, probably one of the top 3. And like most websites that have physical stores and locations, they have one of these map features. You go to the map, you can click the geolocation icon, and it will set a route to your nearest retail location. Makes sense, nice and easy feature. Go to the website, click the button, go down the street, turn left, buy a sandwich. Fantastic. But one day, pretty much all of these stopped working. Can anyone see, looking at this screenshot, why they stopped working? Has anyone noticed in the address bar, does it say, go ahead? There's no HTTPS, that's right. So quite a while back, a decision was made by the browser vendors. This page is accessing your GPS location. Your GPS location pretty uniquely identifies you because I'm the only person stood here. That's sensitive data, it's private data. So what we're going to do is we're going to restrict GPS locations, the geolocation API, to only secure pages so that that transmission of your private data is secure. And what that means is if a page tries to access the geolocation API on HTTP, it doesn't work. So you go to this page, you press the location thing, and nothing happens. Now, the browsers did announce this. They did put a notification on their respective development blogs saying that we're going to make this change. Do you think everyone in the world reads those blogs? Raise your hands here if you read the developer blogs for the browsers so that you know what changes are coming. 1, 2. OK, 2 people out of a room full of technologists. And this is a reasonable representation, I would say. Not many people do, not many people can. We can't possibly keep track of all the changes that the browsers are going to make. Some of them will impact you in very negative ways, and this is what deprecation reports are for. If you are using a feature on your page that the browser intends to deprecate, the browser can send you a report to tell you, hey, I've just visited your web page, and on your page, you're using this feature. And very soon, I'm going to turn that feature off, and it will stop working. And you would receive a JSON payload just like this to your specified reporting endpoint. Now, it could be geolocation, it could be web SQL, it could be absolutely any feature. If you're using something and it will soon stop working, would you like to know about it? That's all that you need to ask. And the answer for me is, yeah, if I'm using this feature on my page and you're going to turn it off, I would like to know about that. So ask the browser to tell you. That's all you have to do. So that's deprecation reports, but there's even more. We also have intervention reports. Now, I like these ones because there's quite a few different spins on intervention reports. An intervention is classed as a time when the browser does something other than what you would expect, where the browser takes the decision to not do what you, as the site operator, have instructed, and instead to do something else. Now, there's only 3 reasons that the browser will do that. Number 1, in the interests of performance. Number 2, in the interests of security. And number 3, in the interests of user annoyance. So if you ask the browser to do something that it deems bad for performance, bad for security, or annoying to the user, the browser may choose to do something else instead. That is an intervention. So I'm going to show you an intervention report so that you can get a feel for what that might be. A request to play audio was blocked because it was not triggered by user activation. This is quite an annoying thing. I don't know about you guys, but I have like 100 tabs open, and every now and again, something will start playing somewhere, and I have to like hunt through the tabs to try and find the tab that's blaring out the music or auto-playing the video. That would be classed as an intervention because the browser will now not do that. Another intervention might be an example of performance. Perhaps the browser will load a fallback font instead of the font that you specified because the user is on a low-powered device or has a restrictive network connection. So they say, look, we're not going to load this big font file. We'll use a fallback font. Your application now may look completely different. The user is receiving a different experience to the one that you expected because the browser intervened in the interest of performance. Would you like to know about that? Hey, we get these intervention reports all the time. It turns out a lot of people can't load our fonts. Perhaps there's something that you could do about that to improve your application. So any scenario like this, where the browser is doing something other than what you instructed it, it will send you the intervention report and tell you that this happened. So covering off intervention reports, The last of the main ones that we're going to look at is something called a crash report. Now, right now, there's pretty much only one type of crash report that you're going to get, and we can probably all relate to this one. Very small report, very easy to look at. And the reason down here at the bottom is out of memory. Can anybody guess which browser sends these reports? Of course, it's Chrome. So if your application is exhausting memory on the client and it causes some kind of crash, you will get, again, one of these reports dispatched by the browser for you to collect and for you to look at. You will also get a crash ID. With that, you can go back to the vendor and potentially look at more information around the crash, around what happened. But again, it comes back to the question for me of, if somebody goes to your website and something has gone wrong, especially in quite a big way like this, do you want to know about it? All you have to do is turn on these reporting features. There's no code to deploy. There's no agent that you have to install on the client. This is native browser functionality. The browser is now there to help you. It used to be a window into which we sent HTML and the user would observe. But now it's an active participant in making sure things are working. It wants to work with you. All you have to do is let it know that you want that help. So those are probably the main of the reporting mechanisms. This isn't all of them either, by the way. There are more. If you want the browser to help you, have a look at something called content security policy. This is another really big feature. CSP has actually been around for quite a long time, and it allows you to tell the browser exactly what's supposed to happen on your website. Where do my images come from? Where do my scripts come from? Where's my login form supposed to post the username and password to? It has a lot of security, hence content security policy, in CSP. If things happen on your website that you didn't expect, that you don't want, the browser will report back and say, hey, you told me that all of your images would come from this CDN, but do you know you've got all these pictures on your website that come from a different CDN? Maybe somebody put them there nefariously. Maybe it's just a misconfiguration. Maybe it's an error. But you have the ability to specify what you wish to happen and to know when something different happens. HTTP public key pinning. Is anyone familiar with HPKP? Any? So this is a super powerful cryptography feature. And it's actually so powerful that it's currently going through the process of being deprecated now, because it turned out it was so powerful that many people deployed it and deployed it incorrectly or with mistakes in their configuration. And it could actually render your website completely inaccessible to the browser. So we're actually going to see HPKP being deprecated, certainly by Chromium, which have actually announced it, and potentially by the other browser vendors as well. But certificate transparency. Has anyone heard of CT? I often find this. We have these really cool features, and it's not that people don't want to use them, it's just that nobody's heard of them. Certificate transparency allows you to know about every certificate that's been issued for your domain. If you are PayPal.com, you should be the only person that ever has a certificate for PayPal.com, because it's your website, it's your certificate. And if somebody else manages to get one, if somebody manages to trick an issuer, to bribe them, to compel them in some way, to give them a certificate, we can make this other person look like PayPal.com when they're not. Certificate transparency allows you to detect that. You can know every single certificate in existence for your domain name. Have a look at that. It's going to be a really powerful feature. Next one, feature policy. So we talked about geolocation earlier. Geolocation is a feature in the browser, and there are many, many other powerful features like geolocation. Access to the camera, access to the microphone, access to local storage, vibration, notifications. There are lots of powerful things that applications can do with the client now. Perhaps you don't want anybody on your application to access the user's geolocation. You can disable the geolocation API on your website. Now, the biggest protection here is usually if you're embedding third-party content. What if you have your website and you load an ad into your website? The advert comes in, and then the advert accesses the geolocation of the user. Maybe the camera, maybe the microphone. All the user will see is the request for microphone access whilst they're browsing your website. They will not know that it came from the advert, from the third-party content. If you have no need for microphone access on your website, you can disable it. to make sure that it can never be abused and it can never be used in the wrong way. Feature policy allows you to take control of all of these powerful mechanisms. And again, if you block microphone access and somebody tries to access the microphone, you can ask the browser to send you a report and say, hey, this website, your page, trying to access the microphone, and you said that we shouldn't allow microphone access. That would be handy to know, especially if you don't expect anybody to be using the microphone. Bottom middle now, coming towards the end, the XSS auditor. XSS, cross-site scripting. Very, very common attack on the web platform. This is when somebody manages to get JavaScript into our page. Really common attack. A basic example, let's say you have a comment or a review section. I go to your homepage, I type in my 5-star review, and you want that review on your homepage. But I type a script tag into the comment field. You take the comment and you put the script tag on your homepage. I now have JavaScript on your homepage. With JavaScript, I can do pretty much anything I want. Now, browsers, especially Chromium, has something called the XSS auditor built in. Again, this is a native built-in feature that is designed to detect attacks similar to that. This is enabled by default in Chrome. This works all day, whether or not you've configured it. If a user comes to your website with Chrome browser, and that browser thinks an attack is taking place, the browser can refuse to load the page and say, no, we've got this page, and it looks like there is some hostile script here. We're not going to load it. So it's already doing this, whether or not you know about it. The question is, do you want the reports? Because if you ask the auditor, if the auditor detects an attack, it can send a report to you. And it will even include the script. It will say, hey, this is the JavaScript we found on your page. This looks hostile, so we blocked it. So this could already be happening, and you wouldn't even know. You need to turn on these reports. And the last one, OCSP, the Online Certificate Status Protocol. OCSP is a great performance and privacy feature. If you haven't heard of it, have a Google. It will make your web application faster, and it will protect the privacy of your users. If you want to know if it's working, you can enable reports and say to the browser, hey, we're supposed to have this feature turned on. If you come to our website and it's not, and there's something wrong, please tell me. The browser can help you. This doesn't cost anything to enable, and it's easy to set up. So hopefully, we can all go away and have a look if any of these mechanisms would be useful to you and your applications. Thank you very much.